Hey, I think we're live. Andrew, can you give me a thumbs up if you can hear me on the chat there? I'll just wait till I get some confirmation that bit of an echo. Okay, let me see what I can do. Is this any better? How's it now? All right, cool. Yeah, so I have been kind of head down in client work for the last couple of weeks, and I'm looking for a change. And I thought, why not do a bit of a live stream, doing something I really enjoy. And something I really enjoy is looking at different parts of QGIS and trying to work out if I can make them faster and optimize them away. Um, I don't know. I just enjoy it. It's kind of a little puzzle. It's really satisfactory if you can find something that was slow before and turn it a bit faster. Um, and it's actually often quite easy to find uh, little optimizations and little kind of shortcuts you can do to stuff. So I asked before on Twitter and on Mastodon if anybody's got some suggestions of stuff they wanted to see improved. And one suggestion was coming from Kylie. She said that she had an issue with CSV files. So with really large CSV files, when you import them and then you save the project and then you go back to reload the project, there's a massive delay there. So I thought that's a good one to have a look at first. But I'm just trying to grab the data that she suggested, and I'm waiting here, and it's saying, please expect up to 3 hours for the download to complete. So yeah, I don't think I'll use that data set unless this decides to respond quickly. It looks like it's kind of churning away somewhere on a back end here before it'll even give me the download link there for that CSV. So I'm gonna try. I guess I'll try something different, and I'm going to mash up my own CSV first off, and then we'll try pulling it back and see how that goes. Um, what have I got here? I've got my latest copy of QGIS straight from Git. I'm using Qt Creator, and so this is the kind of master copy of QGIS that eventually will become QGIS 3.32. And the other tool that I'm going to be using quite a lot is one that's called Hotspot. So I'm going to fire that one up as well. So here's my hotspot. This one is the tool I use most of the time when I'm trying to profile and see what's taking a bunch of time when something's kind of processing away. Um, this is my go-to tool. So I'm just going to start up my QGIS and make a big dummy CSV that I can use as my sample data here. While this other one keeps sort of processing around that website and see if I can eventually get that actual data set that Kyla said she was having issues with. So I'll start, I guess, by just grabbing a massive data set. What have I got here? I don't know. I'll try this one. How big is this? 3 million records, so it should make a pretty big CSV when I dump that out. Just going to save this out to CSV. And actually, probably what I'll do is, I don't know. I assume that the data set that was being problematic was probably like a CSV with point locations in it. So I guess what I'll do first off is I'm just going to rip out the centroids of this. This polygon. And actually, while that's kind of burning away, so this is how I'm going to do stuff. I'm going to use my hotspot tool and attach it to the copy of QGIS that's running here, which is this guy here, and just kind of start recording while this is thinking about something. So at the moment, it's kind of doing that centroid extraction. So hotspot will let me sample what's happening in that QGIS session, and I'm just going to record a bunch of stuff, and now I'm going to have a look and see what results this gives me. Yeah, it's going to think about this for some time. So one thing that's important to note is right now the QGIS version I'm running is a debug compiled version, so it's inherently slower than a release build version. But I'll do my profiling initially in this debug one because I'll get more fine-grained results, and then if I find any good optimizations, we'll test it in the release version as well, because that'll have slightly different behavior as the compiler kind of does different stuff when it's debug versus release. So we're still waiting for this tool now to do some downloading. Oh look, I can actually get my real data set here now. So let's grab this one too. Chuck that there. How big's this? Well, that's saying it's got an hour left to download, so maybe we'll keep on going with my dummy data set. I tried to do a smaller extract from that data set as well, so let's see how big this one is. What are you going to do? 13 minutes. Okay, well, you can just kind of burn away in the background there too. Anyway, I've got to wait for this tool. This is an annoying thing about it is sometimes when you start it up, it has to download some debug info from Fedora that I don't even really care about, but I just got to let it do it the first time. Okay, in the background here, my centroids is finished, so I've now got a point data set, and I'm going to go. I'm going to run this one, add XY fields to layer, so that I can extract out my Latin long fields as XY fields. And I'm going to save this one out to a CSV. So I'm just going to chuck it in here somewhere. Let's chuck that there. Okay, so you can go and think about that. And you're still thinking. Come on, computer. We've got a few more people who have joined us. Say hello. Welcome to this afternoon's stream. What I'm trying to do right now is I'm just generating some dummy data that we're going to play with. But the initial initial problem I was going to look at today is about the performance of reading CSV files in QGIS. So we're going to see if we can um, speed this up at all. There might be some nice low-hanging fruit that we can get, and let's see what we find. I haven't prepared any of this in advance, so we might find nothing, or we might find some fantastic stuff. But that's kind of that's the game. So I'm just waiting now while I'm making a massive CSV file that we can use as our test data set. It's burning away there in the background. If you've got any other things you want me to look at, feel free to put them in the text chat in the stream. You're still thinking away. You're still thinking, okay, good. So, let's have a look. Where did that window go to? There we are. Okay, so now I've got a one gigabyte CSV file. That should be a pretty good data set to test with. Right, so that's there. Let's throw away all that input data. We don't care about that anymore. You are still thinking away. Okay, now I'm going to pull in my CSV, and I'm not sure if this is the right process that the issue was originally kind of reported for, but I'm going to try it this way. So I'm going to try it using my data source manager delimited text, loading it in this way. There's actually two different ways we can load CSVs to QGIS. So one is using this data source manager delimited text, which gives us a bunch of options about how to kind of interpret that CSV and to throw away field names or handle the geometry and such. But the other way I could do it as well is I could just add it straight as a vector layer, and the difference is how the backend kind of reads it. So if I load it through the vector thing, it'll be using GDAL to read that CSV. So that's kind of one path of reading CSVs. This one, it will use an internal QGIS driver for delimited text, and that's a completely different code path. So I'm going to assume that it was this one is the one that was the problematic one originally, but let's just have a look. So I'm just going to have to set this up. I'm going to say my geometry field is that X and Y field over here, where we've got the Latin long, and our CRS is it's in Latin long, so it's we'll say it's WGS84. What else do we need to do here? That all looks good. Good. Okay, let's just add that. Where did my hotspot go? Start that up again. And actually, while this is thinking here, I'm going to try and see if I can get a profile of what QGIS is doing right now. So at the moment, it's kind of thinking about adding that CSV. I don't actually have it in there yet, so there's something is going on in the background. I'm going to see if I can sniff in here and see what's actually happening. So I'm going to have a look in hotspot on this flame graph view. So this kind of gives us a view from the bottom up of what's actually happening in that QGIS session right now. So we've got QGIS vector layers being created, and it's making a delimited text provider here, and then it's gets stuck in this one. So QGIS delimited text provider scan file. and that's basically the function that is using up all this time right now as Qt is kind of thinking about loading this layer in. Let's have a look and see what this is doing. So we've got a fair bit of time here. What's it saying? About 9%. We can see kind of in that thing is uh, retrieving values from a list. So using um, the get operator on that list, and that looks like a good candidate for an optimization. What else have we got here? So there's another one there. So that's only 3% of the time at the moment, 2.5%. But these two combined, so we've got about 12% there. I think we could probably optimize quite a bit of that. Here, what have we got? So this is doing string to double conversions as it's scanning that file. Probably not a lot we can do there with that, but let's have a look at that. Some string to integer conversions as well is taking a little bit of time, but that's only kind of 1% of the time, so not too much point in looking at that one at the moment. The big one obviously is this one, so this is about 80% of the time here is in delimited text file next record. And this one kind of breaks down into a bunch of different things. Okay, I'm going to start off with this one. So in this scan file. So let's look at this one. QGIS delimited text provider scan file. I want to see if I can find any good opportunities for optimization there. What am I looking for? QGIS delimited text file. I've got to spell it right. Scan file. QGIS delimited text provider. Okay, so here's the bit of code in QGIS that this session is kind of thinking about right now. And what's this actually doing? Scans a file to determine field types and other information about the data. It looks like it also builds spatial index. So we know here somewhere there was a portion of the time, so 10% of the overall time is in that array access, and this looks like, again, this looks like a really good candidate for us to chop off maybe 10% of this time overall. So I'm going to see if I can find in this function where that is happening. So what have we got here? We've got a bunch of kind of setup stuff. So here it's retrieving indexes of different fields and things from the layer setup. So that's all kind of not so useful. So we've got this next record thing, which we knew that's where the bulk of our time is spent. So we'll look at that one next, but let's have a scan through this initial scan file function first. So here it's saying if we set the layer up as a WKT, we didn't in this case. We were just saying it was a XY geometry. So it could be in here that this 10% of the time is being taken. I'll come back to that in a sec. So here's a bunch of these list index operators here that could be where the time is being taken. Quite a lot happening in this function. Let's have a look. Let's have a look what's happening up here again. So what are all these ones? List of bools. Could be int, could be long, could be double. All right, so it looks like what this is actually doing is it's scanning through all the records in the CSV, and then these arrays here are per field. If that field could be an integer, could be a long, and all these other kind of double data types here. So as it's kind of scanning each record in that CSV, it's going through each of the fields and building up this overall list of what those fields could be. So we get that record, we get the parts. What's this one? A list of strings. Okay. So one thing that we can see here, actually, if I look in my profile, a lot of the time when we're using this operator on a queue list, it can do this thing. It can detach the list. So queue list is a Qt container, and it's implicitly shared. So basically, it's cheap to make a copy of, but when we try and change the data in it, then it incurs the cost of a copy. And right here, this operator here, it has to detach the list because it's being used to, or could be used to modify the data in that list, and then a non-negligible amount of time uh, is here determining if that list, the actual data underneath the list, needs to be detached and a copy of it made. So a really easy way to avoid that is if we know that we're not actually changing a value in this queue list, we could change this from that to this value method, which is const. So this means it doesn't need to detach ever. So potentially, if I replace all these with the dot value, then we'll get rid of this kind of 10% of the time here, and we might save some cost there. But the other thing I could do is a lot of the time these Qt containers will get better performance if we just swap them across to a like standard C++ container. So maybe I could do that here and save some time. But let's just try this. Let's try this and we'll see if we get it. Swapping these ones across so that we don't incur that detaching cost. I'm just going to swap all these ones over and see if this helps at all. So that's this one. And actually this has got a little test in here as well to say, basically checking if this list has got enough values in it to retrieve the one at this index, and we don't need this check anymore because that's baked into this dot value method. So that will return an empty string if the list isn't big enough anyway. So it's kind of, there's a redundant check happening there. So let's get rid of all that. Don't need that. Don't need these. Kill those ones off. And was the same up here. So what else have we got here? Okay, so now this is going to go through. Oh, so that's where it's split the record from the CSV into the different parts based on whatever your separator is, and now it's looking at each one and determining if it could be what the field types could be in here. So I can fix this one up a little bit because we don't need. We'll do that. So we again keeping avoiding that potential detachment cost and the check that it needs to do if it has to detach, which wastes a bunch of time. So what's this doing now? I mean, we could improve this, but I don't think it's even showing up really in our profiling. I can't see any kind of any significant amount of time spent on this appending, like the growing the list basically. So I'm not going to bother too much about that. What else have we got here? So oh, I didn't like that being const. It should be that. And okay, let's just have a look at that. So I'm just going to rebuild that, see if that made any difference at all. You can go, let's kill that one off and do this again. So I'll do the same thing again, add my CSV, XY, etc. Add that, and I'm just going to resample that now with those changes, and we'll see if our profile changes at all. So it hasn't yet, so we've still got a whole bunch of these detached costs. It's gone down a little bit, because before we were looking at, oh no, it's about the same still about 10%. So let me see. It could be, let's kill that. Don't care about you, Ray. I suspect it could be these ones. So what I'm going to do here is change these ones across to, from the Qt container to the standard C++ container types, which don't implicitly share. We don't need it in this case. We don't want the extra expense of that kind of implicit sharing. So let's just change all this stuff to the C++ standard ones. This looks a bit weird, but okay, let me see if that makes any difference now. Oh, okay, so it's not compiling. What is this doing? Okay, just gotta fix some stuff up to get this compiling okay. You happy now? Yeah, right. Okay, now we'll test again, see if we've made any difference to our profile again. Okay, so it looks different now. So we've got rid of, so it has made quite a bit of difference. It's made a difference there at least. So we've got rid of a lot of the cost of that list attachment from the Qt list object. That's disappeared from my profile here. Um, there's still a bit there we could look at, a bit there we could look at, string to int stuff. But although here's the thing, we've swapped out that we've replaced the Qt cost with this. So I really need to now do some number testing, some timing, and actually test if it's made a good difference here. But I'm going to have a look in here. I'm going to have a look at this guy because this is where the bulk of our stuff is, bulk of our time is. So this is kind of where we'll get the best results. Let's have a look. So in next record, delimited text file, next record. And so about 2% of the time there is in list clearing. Something in next line. Most of it's in this guy, pass quoted. What's pass quoted look like? What's this one doing? Pass quote delimited fields where quote and escape are different. So it looks like a fair bit of the time here is kind of split between different string handling methods. There's a string search there where it must be looking for that delimited character. Some string building here. Let's have a look. How long is this function? See if there's anything obvious in here that we can fix up, we can optimize. So there's a bit of time. So what have we got? About 5% of time is in building a string here. So appending results to a string. Let's have a look if there's anything we could do there. String which to accumulate next field. It possibly is. So here we've got another bit where it's checking for a Qt implicitly shared detachment, and that's probably coming from this one here. So buffer is what's buffer? The string. So this is getting one character. What's that? At a position from that string. So this one here is not a const caller, so it's doing that check for detach. And I think if we replace that to the, well, I mean, the easiest way is to do this. And that'll prevent it from doing that detach and that detach check. So that alone might make some difference. But what else have we got here? So there's another one there. Give this a test and let's see what this does. Anymore? No, so let's test that. Go. Add my CSV back in here. And let's have another look inside and see what's happening. So we're looking in this one, pass quoted. We've still got, what have we got here? So we've got rid of the cost of the detachment, so that's something. Still a fair bit of time is spent in that, and there might be some opportunities to improve that. What else have we got here? Append field. What does append field do? So that must be actually adding the bits adding each individual field value as it finds it to the overall list. Don't know if there's much we can do there. There's a bit of. Yeah, we'll leave that one for now. Yeah, we'll leave that one for now. So we've got this Q string contains quite a bit of time spent there. I don't know if we'll be able to do much there. But I will see if I can get this bit optimized away. Because potentially, so this is getting individual characters from this string buffer here at certain indexes. Increases the index there, increases the index there. So I wonder if we... So this one must be filling up that buffer. Yeah, okay, so that's changing the buffer there. I wonder if using a string view here would help us. So there's this Qt class QString view, which is like equivalent of the C++ string view. It's possible if we use a view on this, we might get better performance. Let me try this. Let's just see what happens. here, instead of reading it from that, I'm going to read it from the string view. So all right, let's see if this makes any difference. Still a decent amount of time. 10% of time is spent getting the characters from that string view, so it hasn't made a big difference. But the other thing, what's this? Dylan characters contains that character. Because yeah, the other one we know spending about 15% of time on is this contains check. So where's contains being called here? Here. Nope. So just there. There is something we could do here, because most of the time the delimited characters and the quote characters and that will just be a single character. So I think this code here is basically saying if you've got two options or multiple options for the delimiter in that CSV, like a comma or a semicolon, whatever, then it's built those up into into a concatenated string, and it's seeing if that current character it's analyzing is inside that string. But most of the time, these would be a single character. So that could mean we could possibly, I mean, in this case it is. Let's try this. I'm kind of curious to see if this works. So if we're only a single character delimiter, then we're going to go and say, just do a straight equality check. Otherwise, we'll do the contains, because I'm making the assumption here that this will be much cheaper than that contains check. And why don't we do it for all of these ones? What was that one? Quote character, escape character. escape. Okay, let's fix that up as well. I'm going to try this as well. Whoops. Let's see if that. No, I can't do that. Alright, let's see if this makes any difference. Hmm. Nah, but I think what I should do is do something like this. Is that a test? Okay, this is looking better. So the other thing I wonder, where's the append? So this is going through and for the current field value adding one character at a time. And the problem with adding one character at a time is because it has to keep reallocating the memory for it, and that ends up costing a bit of time each time we do that. So we might be able to do something like this. and basically reserve all that, the maximum space we would need for the field in that line, because we know the overall length of the line, so the field, individual field can't be more than that overall line length. So maybe if we do that allocation once up front, it'll save us the repeated cost of continually growing it. Let's have a look. So we're still got a bit there. Hasn't made a massive difference, but let's have a look. Let's have a look overall how this is going now. Actually, there's a much bigger optimization we can do here anyway, because at the moment this is scanning for every single line in that CSV file to work out the data types. I don't think it needs to be scanning every single line. I think this could be have a hard-coded limit and only scan up to whatever the first 1,000 lines, first 10,000 lines or something, and it's going to be good enough. I don't think it needs to actually scan every single line to determine the field types. If you kind of sample the first 10% or something, then that should be a good enough although actually there it looks like there is an early exit pass here if we are doing skip full scan. Anyway, what I'm going to do now is I'm going to have a look because the original issue that was reported was when we reloaded this project. So let me see what happens. If I save that project, close it down, reopen it. So the reported issue was that reloading the project with the CSV included in it would take much longer than just adding the CSV in the first place. So let's have a little sniff here and see what is actually happening while that project is kind of doing nothing, sitting and thinking. Is it doing the same thing? It is. It's calling scan file here. Scan file. So I guess the question is, why is this needing to scan the file again after when we're reloading the project? Let's just have a look what this is actually doing. Okay, so in this case, it looks like it is building up an index. So that's why it is having to do that full file scan. So this build index is true. So that's why it's doing that initial scan. So the interesting thing is when I first added that to QGIS, that project, that file, All right, sorry, I thought there was an option in there that we could disable that index, but it looks like there's an inherent index that's always there, but then we can opt into the spatial index in that subset index. I'll just see what it's doing now, see if it's stuck in the same spot. So what are we doing now? So my QGIS has finished loading that project. And so that sample I just took then was actually of it rendering that CSV file, which we kind of expect to take forever because it's we didn't choose to build the spatial index, so it's going to read all of the rows in that whatever 16 million thing CSV because it doesn't know which ones are actually in the viewpoint at the moment. Okay, so let's close that back down again. I'm going to do this again. I want to sample it again where it's loading the project. So it's definitely this same function we've been looking at, that parse quoted bit that splits the line up into the different components of it, that is the issue here. So it's still running through every line in the CSV when we open up that CSV and splitting it out into these components. I guess the question is, what's it actually doing with this? Because we're not building that spatial index, but so it's still trying to work out the field types like it did when we first loaded it. Hmm. So what I'm actually thinking here is, if the whole point of that loop when we open the file, when we open the project and it's scanning over the whole CSV again, is to determine the actual field types based on the data in the field. So to determine how to interpret those values. If all this information was instead saved in that project instead of calculated dynamically when we load that project again, then we shouldn't need to do any of this kind of scanning in this case, because we could just use the values that were actually saved in the project for that. And then that would save us the whole cost of this, and it kind of it just blows away any other little optimizations we want to do to this code here. So this is where I come back to. There actually is some early exit path that's already built into here, but it's only when this flag is set that we're allowed to do that. So
if this little flag here is set, then we jump out after the first two features. So I just want to see why this one, how this one actually gets set in the first place, this skip full scan flag. And it looks like the only place that gets run, get that this optimization flag gets set is in this guy, the limited text file scan task, which is coming from the dialog. So when we're doing it in here and we're going like that, and then it's doing this thing in the background, that is allowed to skip over and only scan 2 records if it wants to. But when we actually load it as a layer, it's still doing that whole 16 million record scan. Here's a really coarse test we can do. Let's kill that. Kill that. If I go in here, let's just remove that check temporarily. Let's see if this loads almost instantly now. It does. It does, but at a cost, because now our layer is not showing at all the different yeah. So it looks like the other thing that this loop is doing is building up the number of features in that layer that's used for other, there we go, that's used for other things in this CSV provider. So that's another thing that is doing initially up front. It's doing that full scan, so it knows up front how many records are in that whole layer. Right. Okay, so the outcome there is basically it doesn't look like there's any low-hanging fruit in allowing us to skip this whole upfront file scan. So that option's kind of been locked out, at least without kind of massive changes to this code, which I didn't really want to do in this session. I was kind of looking more for micro stuff, but that's good because it means we can jump back to what we were looking at originally, which was our pass quoted function, and see if there's any kind of micro stuff we can do there. And what I'm going to do now is I'm just going to grab I'm just going to see if any of the changes that we've made now have made any impact at all on the speed, that overall speed of that read. So let's have a look. So what do we do? So what I'm going to do is I'm going to start with, oops, I want to do that, I'm going to start with going back to what it originally was. And I'll just make a little Python script that times how long it takes us to open up this project. I think that's the right syntax. Let's see. Yep, good. All right. So let's get a initial before time for opening up this project, and then we'll pull back in the changes one by one and see if any of them have made enough of a difference to be worthwhile pushing up. So I just wrote a little script here that basically makes a QGIS project, starts a timer, reads in that project file. So this is where it's doing loading in all the layers, and it's doing that full scan for the CSV. And then at the end it should print the elapsed time. So we'll just wait while this thinks away of what it's doing. And it is taking a long time. So I can, oh, there we go. Okay, so there's so that's our before figure. If I wanted to do it properly, I probably should do it a couple of times, but I can't bother waiting for that again. So, all right, there's our before. So, now I am going to, okay, I'm going to start with the ones that I think probably would have the biggest impact, and we'll test each of them in turn and see if any of them did make a good impact. So I want, in this case, I only want the one where I made was reserving the size of that field in advance, because I think that is probably, I think from memory, if I do this, a resize 0 as opposed to a clear, I'm fairly certain a clear frees up all the memory that's been put for that string, but this one keeps the memory allocated for it, but just resizes the actual filled part of the string back to 0. But let me double check that. While resize will grow the capacity if needed, it never shrinks capacity. So that's the one that we actually, this is good. This is the one we want. So clear would free up that whole space reserved for that string in memory, and then as it kind of grows again, if we're putting more characters into it, it has to keep reallocating that. But if we use resize 0, then it means it it's already got that memory allocated. We're not kind of incurring that cost twice. So I'll put that one in there too. So what are we doing here? So reserve space for field value. So I'm just going to put that in, and then I'm going to stash away the rest of my changes, and let's see if our loading time is any shorter than that one, than our before time. Again, it's not very scientific. Hey Raymond, good to have you on the chat. We're just looking at the moment. There was somebody was reporting that if you have a big CSV file in your QGIS project and you've added it initially, then you save the project and you go to reload the project, then well, they were saying it was taking longer than it initially took to even add that CSV file in the first place. So I'm just looking at what's actually happening there to see if we can optimize any of this away and make it faster. It doesn't look like there's any massive ways we can skip over what it's doing in the background here. So it's actually kind of reading that whole CSV, and it's doing it to work out field data types and also the overall feature count. My gut feeling is a lot of that could be optimized away. Like we could be a bit more intelligent about how what we need to know up front, but that's kind of pretty in-depth changes, so I don't want to go too far down that track in a stream like this. So at the moment, I'm kind of looking for little micro optimizations we can do in the actual part of the CSV reading that's parsing each line of the CSV, because that's what this is doing millions of times right now. It's going through that whole CSV and splitting it up into those the tokens. And actually, that does make me think, because one of the reasons why I couldn't do, why I didn't want to skip that whole initial loop was because that was also getting the feature count. And I wonder if we just we're not actually using the field values there, so maybe we could speed that up by just skipping over everything that's not related to just getting the feature count up front. But anyway. All right, so what have we got here? So this is, so we've got it down to that. How much have we cut the time down by? Let's just have a quick look. Yeah, we got 3% off the time. That's something. So that optimization, I'd say, is worth it. What I'm going to just do is I'm going to run that again, and I'm going to do my profile here, and I'm just going to have a look and see with just that one change in there what our biggest kind of remaining bits were, and then see which other optimization I'm going to benchmark next based on that. So this is where all the time is being taken in loading up this project. It's scanning the CSV file, reading all the 16 million records in it, and mostly it's in the bit where it's actually splitting up each line of the CSV into the different fields in there. Okay, so what I'm going to do is I'm going to get the next little optimization we tested. And I'm going to try this one. This one where it's based on the assumption that most of the time there'll be a single character in the delimiter being used instead of multiple different delimiters. So let's just do that one. Get rid of that. That did almost nothing. Don't want that one.
Hmm. Yeah. Let's grab that. Download that one. Alright. Okay. So this was our before target, whatever that is, 110 seconds. Got it down to 107 seconds with our initial kind of little optimization, which is something, but I'd hope there's some more. So let's see what this one does. Here's actually our proposal in for a QGIS grant at the moment where all of this layer initialization would be deferred. So instead of right now, when I open my QGIS project, it's doing a whole bunch of layer initialization stuff. So kind of working out the feature count, all the geometry types and all that kind of stuff. Or if it's like a WMS layer, then it goes off and asks for the get capabilities and gets that big massive document and passes it. So the proposal is basically that all that kind of stuff should happen after the project loads in the background. So you'd load your project, it would load kind of instantly, and then in the background, those layers would do all that kind of setup initialization stuff without blocking you. So I could still be using the rest of the layers in my project while this CSV does its setup kind of groundwork. And if that happens, I guess it kind of makes a lot of this moot. But all right, what do we get here? 104 seconds. So that kind of shifted off another, cut off another 3 seconds. So what have we got now? Let's go that divided by that. So we're kind of down to about 5% of the overall time that we've chopped off. So that's something. And I'd say that's getting worthwhile. What else did we do? What was our other little candidates here? I don't think this made any difference at all. This changed into a string view, so that was so I'm not going to care too much about that. What else did we do? Oh, we tried this one, changing that away from that Q list to a vector, to the standard C++ one. Let's see if that one was made a appreciable difference to the overall time. So that's all that stuff. That's that. Okay, let's see how this one goes on its own. So now our goal is to beat 104 seconds. See what this comes back with. While that's going, let's have a look back here. See if there's any other clues. So I wonder about this one. So about 4% of the time here is being spent clearing a list in that next record call. And I think maybe, oh, yeah, I think maybe there's some good opportunity there to shave off a couple more percent. You're still thinking. But otherwise it's back into that past quoted function that we've been looking at mostly. So let's look at this next record. So we're looking for a clear call in next record. It's in this one. So what's this guy do? Next record. Reads the next record from the file and splits it into string fields. So this is basically reading that line, passing it off to that other thing that's actually doing the splitting. So it looks like this guy has got some logic in here to jump over empty lines. I guess at the start of your CSV, you might have some blank lines at the end of it. So there's a call to clear. There's a call to clear. So it's one of these two or the two combined, which are adding up to this 4% cost here in this list clear. What is this? All right, yeah, I want to finish. Okay. So this one is saying that this actually made a bad difference. So what was that one? That was going back from the queue list to the standard vector. Actually ended up taking more time than before. So it went up 8 seconds overall from our original reference time. So let's run it a second time just to confirm that. But if so, that's a bad optimization. Let's kill that one and burn it in fire. Interesting. So it's kind of not what I expect. A lot of the time, the standard C++ containers are better choices than the Qt ones for just internal stuff where you're not sharing any data around, or you're not sharing the container with other between multiple objects. And so it's this guy here. So 15% of our time now is spent in this standard vector call. And it looks like a lot of that is in increasing the size of it. So why, oops, where were we?
So why would that be? Why would that be getting incurred so much? Hmm. Good enough answer. Yep. So it wasn't an anomaly. It was that is a this optimization has slowed things down. So I'm just going to test one thing before we write that one off uh, as a horrible thing, as a horrible misstep. I'm going to do this. I'm going to go. I'm going to try this. Whoops. Ah, muck that up. Okay, no, it's not going to work. What am I doing? What am I doing? All right, so let's kill that. We don't want that one. Throw that away. What else did we have in our, whoops, in our candidates? All right, let's test this one. So this one was trying to avoid the cost of detaching things by only using the methods that don't detach from those containers. Oops, I still got that guy that I didn't want. All right. So yeah, so that bad optimization put us back to 118 seconds, but we're looking to beat at least 104 seconds. That's the game that we're playing.
So that one's basically null, 104.6 seconds as opposed to 104.8, kind of not. So that's that one. Basically useless. What was our last one? What was our last one here? Oh, that was that string view thing. Well, let's give it a test and we'll see. Otherwise, we have to be happy with our 6 seconds for now. What this one is. Where that one's getting incurred. Oh well. So I was wrong. That string view one made a massive difference. Because now we're down to 88 seconds. So 88 seconds from our original 110. Which is much more exciting. So that's about 20% of the time that we save. Okay. All right, let me give it a test now then. So this is our new benchmark. This is the good bit. Let's chuck that in. That's a bit more exciting. So now we've saved. We're getting into the kind of significant savings. Let's do this again and just have a look now where we're sitting. This guy here still really annoys me, that 10% of time there, but actually I reckon there is something we could do there. Anyway, let's go back here. I think we might be at the end of what we can do in this function. Where's this guy coming from? Q car is space. Yeah, I don't think there's anything we could do there. Penfield. What's this look like? So we've got some list growth here. So what's that? 0.5% of our time. I think we're best off to have another look at this guy here before we finish up. So anyway, our new target to beat is 88 seconds. Let's see if we can get any closer. And I really want to fix up this because I don't like that we're spending 10% of the time just setting these values here. Have a quick look. Okay, I want to see how many times it's actually getting called. So first time we come along, all these ones have only got one in there, one value in those arrays. Then is it? What's happening there? All right, I'm going to try something different here. And instead of having one, two, three, four, five, six, seven, eight different lists here that we're kind of storing all those field candidate stuff in. I'm going to have a single list with a little struct of containing this information, and we'll see if avoiding the cost of multiple lists will help. What do these all default to? This one here is something else that I might need to come back to, but let's just see. Okay, now we've got to get it compiling again. Now what we'll go is we'll go we'll only do this lookup once and then just get everything from there.
Oh, actually, I don't even think we need this because we were initializing all those anyway. But
Shouldn't matter. let's see. Let's see if this made a difference. Okay, trying to beat 88 seconds now. So I guess if we were saying before, it was kind of up to about 11% of the time was in that thing that we're trying to optimize, then maybe we might be able to get this down to 80 seconds if we're lucky. And that'd be pretty good. 80 seconds as opposed to 110 seconds originally. Yeah. Come on, fingers crossed. Well, there we go. 79 seconds. I'll take that. So now what have we got? 79 from our original 110 seconds. Whoops. Why didn't that work? So saved about 28%, chopped off about 28% of the time, and I'm getting pretty happy with that. I'm just going to have one last look before we finish up today, and let's just have one last peek at what's happening here. Whoops. Yeah. Try that again. I've got to let it record for a little while to get a good sample. All right, what's our scan file doing now? So we've got some 2% of time destroying some strings, doing some string to int conversions. Don't know if there's much we can do there. Maybe there's an opportunity here to do more string view stuff. What is our value here? Probably not, because that's just coming straight from we're not getting a part of a string, we're getting the whole string we're comparing, so I don't think that's going to be useful. So yeah, I don't think we'll get anything there. So 3% there. The more list lookups. String things there. I think that's about as good as we'll get for now. And I'm pretty happy with it. We got it down from 110 seconds to just under 80 seconds. So it's not a complete win, but it's also not a complete write-off. So I'm happy to leave it there and push these changes up, get them into QGIS 3.32 so that at least there's a bit of a difference there to that project loading speed. Anyway, thanks for watching. Catch you next time. If you've got any ideas for something you want me to look at next time that's slow, see if we can get another 30% off something else in QGIS, send through put a comment, send through a sample data set, sample project that you want to profile and see what we can do with. And next time I get some free time, I'll have a look.